Have you ever wondered how electronic devices store and release tiny amounts of electrical energy in a controlled way? One of the key components that makes this possible is the fixed capacitor. A fixed capacitor is an electronic component that stores electrical energy in an electric field and has a constant capacitance value that cannot be adjusted during use. A capacitor generally consists of two conductive plates separated by an insulating material called a dielectric. When voltage is applied across the plates, electrical charges accumulate on them and energy is stored in the electric field between the plates. In a fixed capacitor, the capacitance value is predetermined during manufacturing and remains constant. Common dielectric materials include ceramic, polyester, mica, and electrolytic substances. These materials influence the capacitor's capacitance, voltage rating, and temperature stability. The structure of a fixed capacitor is relatively simple but highly important for performance. The main components include two metal plates, electrodes, the dielectric layer between them, protective casing, and connection leads. The dielectric material determines how much charge the capacitor can store. For example, ceramic capacitors are small and stable, making them suitable for high-filled square frequency circuits. Electrolytic capacitors can store larger amounts of charge and are commonly used in power supply circuits. Fixed capacitors are widely used in modern electronics. One of their most important applications is in power supply smoothing. In power supply systems, capacitors reduce voltage fluctuations by storing and releasing energy quickly, which helps produce a stable output voltage. Without capacitors, electronic devices such as computers, televisions, and mobile phones would experience unstable electrical signals. Unwanted signals or noise from electrical systems. For example, in audio systems, capacitors help remove high-filled square frequency noise so that the sound becomes clearer. In radio and communication systems, they are used to control signal frequencies and improve signal quality. Fixed capacitors also play an essential role in timing circuits and oscillators. In combination with resistors, they can control the timing of electronic signals. This principle is used in devices such as timers, clocks, and microcontroller circuits. For example, in a simple RC circuit, the capacitor charges and discharges at a predictable rate, which helps determine time intervals. From an industrial perspective, many major electronics companies manufacture fixed capacitors. Companies such as Murata, TDK, Samsung Electro-Filled Square Mechanics, and Vishay are well known for producing high-filled square quality capacitors for global markets. These companies invest heavily in research and development to improve capacitor efficiency, durability, and miniaturization. For students interested in electronics manufacturing, capacitor production companies represent an important. In conclusion, fixed capacitors are essential components in electronic circuits because they store electrical energy, stabilize power supplies, filter unwanted signals, and help control timing in circuits. Their simple structure combined with diverse materials allows them to be used in almost every modern electronic device. Understanding how fixed capacitors work is therefore a fundamental step for students who want to study electronics, electrical engineering, or modern technology systems.